Okay, so welcome to the second video for section 8.1. This is called the Huntington Hill method of apportionment. So Huntington Hill method for apportionment. Okay, so find the quota as in Hamilton's method. So find the quota. So we're always starting with Hamilton's method, right? As in Hamilton's method. Hamilton's method. Okay, so then number one. So let's let n be the quotient. So let n be equal to the whole number part of the quota. Number part of the quota. So, number two, let's evaluate. And in fact, let me call this n blue. So what we're going to evaluate then is the square root of n times n plus 1. Okay, subscript 1, if the quota is greater than the square root of n times n plus 1. And don't worry, I'll show this by example in a moment. So round up the quota. Round the quota up. Up. And of course the other case is if the quota is less than that value. If the quota is less than the square root of n times n plus 1, then guess what? You round down the quota, right? So round down the quota. The quota down. Okay, so proceed as with Jefferson's method, which I really don't like, right? So proceed as with Jefferson's method, which is changing the divisor. I'm not a big fan of that, but hopefully we won't have to do that for this example, which means you won't have to do it either. So for example, use the Huntington Hill method. Huntington Hill method for the California example. So we're going to still use the same California example. Example above. So I'm just going to copy and paste our results. So let's go back to Hamilton's method. Where is it? The first guy here. Okay, so we found our divisor. So I'm going to take all of this. Copy. Paste. Okay, so let's look at this. What do? We found our divisor by dividing the population of California by the number of representatives. So we have this 465,000. Then we took each population in each district and divided it by that divisor. So let me get rid of these underlines. So we've got our quota as in Hamilton's method. So now, for the Huntington Hill method, what we need to calculate before this Q is now the square root of n times n plus 1. So let's go ahead and do that. So I'm going to call this the square root of n times n plus 1 category. And then we'll have our Q over here, and hopefully that'll work. Okay, so this should be the square root of, well, what is the whole number here? It's 8, and what's 8 plus 1? 9. Okay, once again, this has a whole number 24, so 24, what's 24 plus 1? It's 25. We'll take the square root there. This is 46, so we're going to have the square root of 46 times 46 plus 1, which is 47. Okay, so what do we get in this case? So in this case, we get about 8.48. In this case, we get about 24.49. And in this case, we get 46.49. Okay, so that's what we get for those answers. So Q, actually I need to put this over to the left. I don't have enough room. Let's see, let's move this over a bit. Like so. Okay, so let's put Q a bit more to the right. Okay, so what do I get for Q? So I've done the square root of n times n plus 1. So now I need to relate it to the quota. So which is larger, the quota 8.11675 or 8.48? Well, the quota is less than. So in this case, if the quota is less than, we round down. So we're going to go to 8. Now let's look at the second case. 8.49 is less than, so 24.94 is actually larger than. So we're going to round this up. So 24 rounded up will be 25. And last but not least, 46.94 is larger than 46.49. So once again, we round up to get 47. Oh, what's going on? Help, help, help. To get 47. And we know already that that total is indeed 80, so we're set. Check mark. Okay, so that is the Huntington Hill method. Okay, so now Lowndes' method, I believe, was the last method for this apportionment exercise. So Lowndes' method. Okay, so number 1, you find the quota using the Hamilton's method as usual. So find the quota. Quota using Hamilton's method. Hamilton's method, basically, we divide the population of each district or state by the divisor using Hamilton's method. Step 2 is to add the quota's quotients. So add the whole number part, whole number parts of the quotas, number parts of the quotas, otherwise called the quotients, but that's a bit too alliterative. Quotas. Okay, step number 3. What we're going to do, if the total is too few, so if total is too few, so divide each district's remainder by its respective quotient. So divide each remainder by its respective quotient. Respective quotient, meaning whole number part. That is whole number part. Okay, so then assign representatives from highest to lowest. So number 4, assign representatives from highest to lowest value. Okay, so for example, so use Lowndes method in our example above. Method in our example above. Okay, so let me go ahead and paste. Let's see. Okay, so I've got this divisor. We have all of our quotients, all of this. So the Q in each case so far, let me erase the underlines. Actually, I probably could have left the underlines. So, do we agree the Q in each case is 8, 24, and 46 respectively? So what I want to do now is I want to evaluate the remainder, the decimal remainder, which I'll call, what should I call it, R over Q. So the decimal remainder, what color shall I use? Let's use pink. So we're going to take each of these decimal remainders and divide them by the whole number part. So this will be 0.11, so 0.111675. This decimal remainder is 0.94068. This decimal remainder is 0.94765. And each of those we're going to divide by their respective whole number parts. Okay, so the whole number parts in the first instance is 8, in the second instance is 24, and in the third instance is 46. So finally, what do we get when we do all of this? We should get oh boy, I don't know if I have enough room here. Let's see if I can move this a bit closer because these are going to be decimals. I need to make kind of give myself a bit more room. Sorry. I'll move this. Actually, it's already to the left as far as it should go. Okay, so what do I get for this? I get 0.01395. For here, I get 0.039195. 195. And here I get 0.0206. Okay, so, boy, it's still still going to have to move this over, aren't I? Okay, so let's look at those decimals that we just got. Oh, what's going on? What am I doing? Why am I drawing? So I need to distribute representatives now based on those decimals from highest to lowest. So who has the largest, the final? Let's call this bright blue. So it looks like the largest is 0.03. So that's going to be rounded up. And 0.02, oops, what's going on? What's going on? What are you doing? Is going to be the next largest. And I only had 2 extra guys. So now I get the 8 representatives here. This becomes 25, and this becomes 47, which we know has a total of 80. Wow, that barely fit. So total is now equal to 80. Notice each of these methods basically resulted in the same apportionment. It's exactly the same. So for my example, nothing's really different, but hopefully these make sense. If not, you can always contact me and I will go over it. Okay, I'll see you in the next section.